So, what if I told you that the coffee we drink every morning is actually in danger? Yeah, I know it sounds crazy, but it's in danger. And you're probably thinking, okay, like, well, what do you talk about? What do you mean coffee's in danger? Well, Arabica. Now, I'm sure, just like me, we've all seen this. Every bag of coffee we get, grinds or beans or K-cups or whatever, they pretty much all say 100% Arabica. Well, what does that even mean? What does 100% Arabica mean? Like, what if there's 95% Arabica? Well, what's the other 5%? And that's getting into what I'm going to talk about today. I'm going to talk about how we can save Arabica, improve it, and not just Arabica, but coffee in general. So, that coffee we drink every morning, it's not just coffee, it's so much more. It's a species. In fact, it's probably a species that has so much genetic diversity that is untapped, that many of us will never even taste. And when most people think about coffee, they're thinking about the roast, light roast, dark roast, espresso, cold brews, maybe the brand. Is it an espresso? Is it are you a K-cup person, or are you a fresh grind your own beans at home person? That's mostly what we're thinking about. Or maybe you're thinking about like the country of origin, Ethiopia, Guatemala, Sumatra. But underneath all of these things, and the coffee industry is a name, Coffea Arabica. And that's what Arabica is. It's just the species name of a particular species in the genus Coffea. But Arabica is not alone. There's so many other species. There's Robusta, which is probably, if you've ever heard of another type of coffee besides Arabica, 99% chance that you're probably thinking of Robusta. And Robusta is another species. It's called Coffea canephora. There are other species, another one called liberica. There's excelsa. There's stenophylla, which is really fascinating. There's eugenioides, which is actually one of Arabica's parents. And there's this whole wild forest of coffee diversity, and there's so much potential that the industry ignores for, of course, financial and economic reasons. But because of those reasons, I mentioned Arabica is in danger. Well, what is the danger? What is it facing? So, heat, climate change, drought, diseases, and inbreeding, like severe genetic bottlenecks, price shocks, and all these things. And it's kind of a similar case to bananas. Pretty much all bananas we grow are the Cavendish, and if something ever happens, then that industry will be in big trouble. So my point is that most people are thinking about coffee as just a drink, but today we're talking about coffee as a crop and how we're going to save this crop. Your coffee as a genus. Coffee, as, believe it or not, it's actually an evolutionary accident. It's a global habit, built on surprisingly narrow genetic foundation. It's something so important in our daily lives that it really is irreplaceable, but it's resting on a very, very shaky and thin foundation. And the big question is simple: why did Arabica become so dominant? Why the species? And why not Robusta or liberica or one of the other ones that I mentioned? And of course, you're probably thinking flavor. Sure, flavor is a big factor, but it's also history, it's genetics, agriculture, the old empires, and trade, disease, climate. But how are we going to navigate this map? How are we going to actually save it? first thing we want to do is realize that, as I mentioned, coffee does have a species. So most people think coffee means one thing, but botanically, as I mentioned, it belongs to the genus Coffea. And a genus is like a biological neighborhood. It's a group of related species, and they share enough traits and structure that they're clearly all similar. Sometimes one particular family member might have a talent or an ability that the other one might not have. So that's similar to what's going on in coffee. So they're mostly from Africa, Madagascar, and parts of Asia. And we call coffee that we harvest and grind and brew a bean, but it's actually not really a bean. It's actually a seed. The fruit is botanically called a drupe. Although in the industry people say coffee cherries, but they're not cherries, of course. And once you realize that coffee is actually a seed growing inside of fruit, a woody perennial plant, suddenly the whole crop starts to feel less like a commodity and more like what it is. It's a fruit tree crop with its own genetics, its ecology and diseases, and its own seed handling problems and a whole domestication history. And here's the wild part. Out of the whole big coffee family, the whole coffee trade is overwhelmingly built on two species. Mostly Arabica, and then secondly, as I mentioned, Canephora, which we know in the industry is Robusta. And that's it. That's the basic commercial foundation, and it's like these two species are lifting up the entire daily ritual of the whole planet. Some of us will have it more than just once daily, or more than just in the morning. I'm sure many of you are out there like me. But if you're a hobbyist breeder, even, or hybridizer, crosser, that should be ringing alarm bells in you, because how are we holding up an entire industry with just two species? That seems dangerous, right? I did a talk earlier on pepper species and how it's incredibly diverse, and there's 5 different species at least that are keeping the pepper industry so safe and diverse. But coffee is only 2, and then it's not good. It might make it very easy for industry and economics. The machinery and labor practices are all adapted and customized to one particular way of harvesting and doing things, but everything in life is a trade-off. Everything is a double-edged sword. This doesn't all mean that coffee is like doomed, but it does mean that your species matter. So we talked about Arabica and Robusta, Canephora being main players, but there's also the liberica, stenophylla, eugenioides, and of course Arabica is, as I mentioned, it's the big player. But it also, as I mentioned, it's very specific. It prefers like cool tropical climates and higher elevations, and it's the species most associated with great flavor. More acidity and sweetness and floral and fruit tones and complexity. And Robusta is generally more of like your tough coffee. It's stronger. It is more caffeine. The plant is more vigorous, more disease resistant. Robusta is what is actually what they're using in these instant coffees. So if you're ever having like those instant coffees and it just never does quite taste the same. It's very strong flavor. It doesn't quite taste the same as Arabica. It's probably because it's significantly Robusta / Canephora based. So that's where the standard easy version of the story kind of goes off the rails, because you're probably thinking, okay, well, Arabica is good quality and Robusta is just like second rate. It's the cheap. It's not good quality, and that's too simple of a story here. So the point is that Arabica usually wins on maybe cup quality, and especially in the specialty market. But Robusta is not trash coffee. It's a whole different species and just this different chemistry, different agronomy, and different flavor potential, and very different role in global coffee. It can be bitter and woody and harsh when it's poorly processed and poorly grown, but that's because they're growing it for instant coffee. You know, easier, cheaper, but believe it or not, high quality Robustas exist. And with temperatures rising in our world as they are now, species that can tolerate higher heat like Robusta matters. At some point, it's not just coffee, it's a lot of our crops, and that's really one of my passions. I really love plant breeding and genetics and science, and this is why I'm not all doom and gloom about climate change, because by the time we figure it out, we will had to have addressed some of these crops and make them tougher. But I don't freak out because I know it's possible. I do it all the time. You can easily make a standard crop as it is tougher by bringing in these other species and wild relatives. So it can be done. It's just that a lot of people don't want to do it until they have to, of course, right? But here's another thing that Robusta can contribute that Arabica needs: higher yield potential and more disease resistance and more caffeine. The caffeine actually helps it resist predators. It's actually a chemical defense. And it's funny because Arabica doesn't exactly exist as one of the original coffee species. It kind of just happened. And you'll see this in evolutionary biology and in nature all the time. It's one form of speciation where two species cross by chance, and normally they will create a hybrid that could be sterile or will then back cross to either member of the parent species. But occasionally something very cool will happen, and you'll have two species cross, but then the chromosomes will double, become a polyploid, which I'll explain in a later video. That's a really cool deep rabbit hole we can all join in on. Polyploids really make the world go round in plant breeding. That's what happened with Arabica. In ancient times, the Robusta and eugenioides species lived by each other, and they happened to cross. And instead of an unstable hybrid, they actually, by chance, created a entirely new species because it had a chromosome doubling event, and it then became a tetraploid, whereas the Robusta and eugenioides are diploid. And so that means that now Arabica is it's much more stable, and what you'll see in a lot of polyploids, and why I said they make the world go round in breeding, is very oftentimes if you have a sterile cross between two species or any crop, if you just double the chromosomes, now it has any potential genes, it has enough copies of any potential genes that it may be missing that the other species parent didn't have. And I hope you guys can understand this concept. I'm just kind of like brushing over it, but I'll do a whole video on it later. But essentially it fixes any deficits that it may have genetically. And it often makes, when a crop doubles its chromosomes, it often becomes thicker and stronger and solves a lot of problems. And that's pretty cool, because we do this in the greenhouse or the lab all the time, but it can actually happen in nature like this. And Arabica happened like this. It's just like a freak accident and botanical anomaly, which happened and gave us this wonderful crop. But we have to talk about, as I mentioned, why Arabica took over. So Arabica really, the first thing why it became so prevalent is the flavor. And that's the big thing. It's got that nice floral and fruity flavor. It can handle higher elevations and cooler climates and stuff, but it's really that floral and acidity and sweetness and that wonderful perfect coffee balance that really attracted people's attention. And we assume that Arabica always tastes better, but that's not always the case. You can have really bad Arabica and you can have really good Robusta. Especially the way it's grown. It's just like with grapes and as they say, like the Terroir. I don't know if I pronounced that correctly, but it's how the growing and the climate and geography, as they say, you can taste it in the wine glass. Well, that happens with coffee as well. You can see how the growing conditions really affect the quality and flavor of the brew. But on a base level, all things being equal, the Arabica does tend to taste better, and just people like that. And number two, it was just found first, or it became a part of the global story earlier. It was first cultivated in Ethiopia and Yemen, and Yemen actually became really central to the early history of coffee as a beverage. Hint why the species was even named Arabica, right? But from there, in its origins in Yemen, it moved through trade routes and religious spaces, and the coffee houses and ports and colonial systems and plantations, and eventually the entire world. And it matters because crops aren't just chosen by biology; it's also, like this, chosen by history and humans, and it became culturally significant. And that's number third. Why else? Well, Arabica really has a breeding quirk to help it travel as a crop around the world. And remember I mentioned polyploid? Well, because of that polyploid, it is self-fertile, and that's a huge thing. So when a crop is like Arabica coffee, it's self-fertile. All it takes is one friend of a friend to give you a seed. You grow it out, and you might get one or two plants, and then you don't need any other coffee plants to pollinate the berries and self-pollinate, and then it will just you can save the seeds from those, and it will just increase exponentially over time and grow and grow and grow. And that all came from just handing over one seed instead of starting with a whole bag of seeds in a field like you would need with corn, for example, to ensure cross-pollination. So it's totally remember how I said becoming polyploid made it solve a lot of fertility issues, and you'll see that in a lot of cases that once a plant becomes tetraploid, tends to gain a huge increase in fertility, and especially like self-fertility. And that's huge. That's a big one. So it can go from region to region easily. If it would have needed that cross-pollination, if it wasn't a tetraploid, I don't think that coffee would have become as big as it is today, because it just made it so easy. But as I mentioned, everything's a double-edged sword. Everything has a trade-off, and there's the dark side of this. That if you're self-fertile, you're in a constant state of inbreeding, and so you just see a drastic drop in genetic diversity. So yes, we did keep these things about coffee that we love, like these flavors and the ease of propagation, but we really lost all kinds of genetic diversity, and that's really not ideal. It won the world, but it didn't bring enough genetic armor with it, if you will. it didn't help that the market, the market started becoming tied to its origin, its roast, the acidity, fragrance, and the complexity, and 100% Arabica became a thing. And I don't know this for sure, but I have a hypothesis that the reason why this became prevalent in marketing, 100% Arabica, is because it's just so easy to propagate and grow, and a huge thing of harvest. So I think that these big commercial growers, they want to make life easier, want to make the quick money. So Arabica, all the berries ripen at the same time, so you can have guys go out there and harvest everything in one day, and that's easy. If you want to try some other species like Robusta, the berries don't ripen all at the same time, so you have to keep going back and harvesting. Labor and time is money. So I think that's just my hypothesis that had a lot to do with it as well. But then it becomes this like snowball effect and this doom loop, because then consumers are learning to associate 100% Arabica with quality, and competitions start awarding, well, is it 100% Arabica? The taste testers want it. The specialty coffee starts building language around it, and it just becomes culturally dominant. And the culture does have an effect on biology, for better or worse, right? But Robusta is not. It's not that bad. It's as I mentioned, it's pretty tough. It really is heat tolerant, higher caffeine, which is also a defense mechanism, by the way. Disease resistant and yield. Like these are, and it gives higher crema. I personally love crema. I'm an espresso guy, but it has all these wonderful things, right? So why isn't it grown? And I think it has to do with the harvesting issue. It's really tough to harvest a crop that doesn't ripen all at the same time. It's a lot of money and labor to go back out there and do that. And I think because of that, the industry kind of made Robusta become like a bad word, or low quality. It's a volume thing. It's a instant coffee thing. It's not an elegant. It's not a quality thing. It's so unfortunate, because it does have so much more to offer. And even though it is one of the parents of Arabica, there's so much you can do. You can normally when you have a plant that is like Robusta, it's a diploid, which is normal state, 2 sets of chromosomes, and then the Arabica, which is a tetraploid, 4 sets. Normally, you can't cross between the different, the diploid and the tetraploid. There's all kinds of exceptions, especially in roses, which is one of my professional specialties. But one idea I have is, well, you can just artificially double the chromosomes of Robusta and make it a tetraploid too. Then it can reliably back cross to Arabica, and we can get some of these stronger traits back in there. That's what I would do. That's what I would do. And you would then have to, back cross and make sure you select for uniform ripening. But it's totally doable. It doesn't mean Robusta should replace Arabica. That would certainly affect the industry, and with the harvesting problem, I'm sure prices would really, really go up. But it is its own species and its own strengths and weaknesses and chemistry, and it's important. Even though it is a parent of Arabica, it's not the same. But it's still the other commercial giant, right? But as is the topic of this presentation, we're trying to save Arabica through the forgotten species. And although Robusta is number 2, it's the least forgotten. There are a lot more that are truly forgotten, right? A lot more species. And like I mentioned, although Arabica is a combination of these two, well, with these other species, well, what if we can just create entirely new species to cross with Arabica? So here are the other forgotten species, the other forgotten coffees we're going to talk about. And I mentioned most of these before earlier, but I don't think I talked about racemosa. But we're gonna talk about it because there's a lot out there. There's a lot of other species out there, and I talked about just the extreme diversity that you have with just Arabica and just Robusta, and I touched on this in my pepper presentation, how there's so much diversity even within a single species. Just imagine if you have all these other species and their hybrids and crossing, what we can do. So liberica and excelsa kind of go together. We'll talk about them next. They're extremely underused. They're very big. They're very big plants. But liberica specifically, it is a real commercial species. Probably I would say third place, like a distant third. It's way much less common than Arabica or Robusta. But it's known for big. Like when you think liberica, think big. Big cherries, big leaves, big trees, big flowers, large beans. And the flavor is of the actual coffee made from liberica. It's polarizing. Some people hate it. Some people love it. It can be a little bit smoky and woody and sometimes jackfruit-like. Believe it or not, it's definitely not trying to be Arabica at all, and that's important. And that's the point I just wanted to throw in there. Like, let's not judge every coffee species by how it relates to Arabica. Let's evaluate it on its own merits. You wouldn't taste every pepper on how it relates to like a jalapeno, for example, but I get it. As with any crop with differing species, it has its own. They have their own lanes, and liberica has its own lane, and it does have some cultural significance and importance in other parts of the world, like the Philippines and Southeast Asia. It's important there. But I said these two kind of go together. So yeah, there's excelsa, and excelsa it's kind of complicated taxonomically. It depends on your source and classification. Some people treat it as like a type of liberica. Believe it or not, or part of a liberica complex. But that's going to get too much into the rabbit hole. That could be a discussion for another day. But the important thing to remember is that it's kind of related, but it's not. It's I'll treat it as its own species. I'm going to do that, and it's important because it's gained some renewed interest recently. It's actually pretty resilient, and it's got really unique flavor potential and really unique flavors, as does liberica. Jackfruit and woody and smoky, right? But the excelsa has really deep root systems. It can handle hotter and drier conditions, and it's just something else to work with that shouldn't be ignored, right? But there's some. Let's move on to the other species. There's other ones too, right? And this is a really cool one. So stenophylla is native to West Africa. So automatically we can assume that it's going to have some degree of heat tolerance, because this is where it evolved. And that's true, because it is very heat tolerant, and unfortunately it's been kind of forgotten commercially. It's not really a commercial player, but as much as I said excelsa can tolerate warm conditions, stenophylla can really tolerate even warmer conditions, possibly even drier. And it was kind of rediscovered when scientists went out actually looking for seriously climate resilient coffee options. And so that does give me hope, and that should give you hope as well. But you think, well, okay, heat tolerance, extreme heat tolerance, why not excelsa, or why not something else? Well, what makes stenophylla exciting is because it has a flavor profile that is very similar to Arabica. And the reason that's important is because people already are expecting a coffee to taste like coffee, and when we meaning like Arabica. And so if you have something that is heat tolerant but already has a similar profile, then it just saves one step in the breeding program of trying to like save our Arabica, right? And I think it will play a huge role in the future for improving Arabica and saving coffee in general as a crop. You know, it's going to be essential to future-proofing this thing we love so much, right? Love and need. Right? Flavor and resilience. But there's another one, another species. Let's move on. Eugenioides. And as much as I've talked about Canephora, Robusta being one of Arabica's parents, well, Eugenioides is the other parent, as we touched on briefly. And it's kind of interesting to look at, because if you look at Robusta as an extreme version of Arabica in one way, well, the total opposite of that you can see in Eugenioides. You can see clearly how a Eugenioides and Robusta cross would create Arabica, because while Robusta has that super high caffeine, Eugenioides has really low caffeine, and Arabica is in between. And Robusta has that really strong coffee taste, but the more complex and delicate fruity aromas that comes from Eugenioides. So you can see how it's like the other piece of the puzzle of Arabica's genetic origin. And you might think, well, if it's we already have that in Arabica, well, why do we want to worry about it or use it? Well, because it's just a hidden source of valuable genetics. We could always improve the flavor of Arabica because it's so delicate and can be so sweet and so delicate. It can have way depending. I mean, it's all subjective, but it can have really good flavor, even more so than Arabica. So we can keep doing this dance. Back crossing to Robusta get strength, and back crossing to Eugenioides to keep the flavor. Or maybe what I would do is a Eugenioides and stenophylla across. That's what I would do. You might have to work on the caffeine a bit, but the possibilities are endless. And I mean that excites me. That really excites me. And hopefully these plant genetics and crop genetics excite you as well. Now there's one more thing, and that is Coffea racemosa. That's another species, and I just wanted to briefly mention that it's another great one for climate adaptation. It's really known for its drought tolerance. Racemosa, extremely drought tolerant. Also valuable for its resistance against coffee leaf miner, and that's a huge one. So not only like drought tolerance and leaf miner, but also fungal pathogens. It has a lot of great fungal resistance. But again, this is the problem we always face in breeding. It's a good problem. It's a fun challenge, because the Coffea racemosa, it's very small, very low yielding, and very much lower in caffeine. So many hurdles are overcome, but the genetic resources are out there. What we needed to solve this problem is out there. And to reiterate, coffee meaning like Arabica, it has a very limited genetic foundation because it is self-pollinating, and that low diversity always means high vulnerability, no matter what crop we're talking about, right? So there's so much we can do. These disease and pests, use the racemosa, the climate, we use stenophylla, excelsa, the coffee bean size, we could use liberica. New flavors use eugenioides and liberica, right? There's so much we can do. And I truly believe that the future is in diversification, and breeders are doing this. People are working to solve the problem. but there is a problem, and I just wanted you all to be aware of it, because I think it's extremely fascinating. I think it's extremely important, the lore of this drink that's a part of so many of our daily lives. And this just excites me because in the future we're going to see so many different flavors of coffee. We're going to see, I think, hopefully in the future, coffees that are much more adapted and could be grown in different parts of the world. So once they're grown in different parts of the world, just like with wine, we'll get new flavors in that way. So the future is bright. Coffee will become more sustainable. But hopefully from now, I hope you gathered that there's so much history and story and culture between that cup you have in the morning, and there's so much drama and danger. This easy way out by growing Arabica, and now we have problems to face because growing these acres and acres of one single crop allows pests and diseases to proliferate more. So yeah, I am just going to fill you with these thoughts to ponder, and also with some quiet confidence and hope that the future is bright. And perhaps even if you have the resources yourself, you can start trying some of these coffee crosses yourself. I know that I would love to. I'd love to do a coffee breeding program, but again, it's a tropical crop, and that does limit what you can do with it. But still, it's been such an interesting deep dive to about, okay, it's just something we drink, but there's all these cool species that can really improve it in the future. And if you enjoy these type of deep dives and talks and backgrounds of these everyday common things that we drink, then certainly like and subscribe. It really helps the channel, and leave a comment below. Let me know if you love this, if you hate it, if you want to see more of these type of things. And I'm here for you guys. I hope you gained something from this presentation, and I'll see you next time.